Twinkle Twinkle Little Star. All of us must have heard this poem at least once in our life. While listening to this poem or while staring at the night sky, a question might have struck to you that why actually the stars twinkle? In this video, we are going to discuss this particular topic, the twinkling effect of stars. Before moving further, we have to understand that stars do not actually twinkle on their own. In fact, the brightness of stars is always the same. That is, the illuminance of stars is constant till the star is alive. It is the atmosphere wrapped around the Earth which is responsible for the twinkling effect. Don't believe me? Let me tell you a fact. Astronauts do not see stars twinkling from the space, as there is no atmosphere in the space to cause the twinkling effect. The stars are very far from us. To give you a sense, the nearest star from Earth is more than 25 trillion miles away. That is why, when we look at them in the night sky, they appear to us as tiny point-sized sources of light. When we look at a star from Earth, the light from the star travels through space and then passes through the atmosphere before reaching our eyes. However, the Earth's atmosphere is optically denser than the outer space. So, while passing through the atmosphere, light rays, instead of moving in a straight line, bend slightly. This is known as refraction of light, and since it is caused by the atmosphere, it is called atmospheric refraction. After these refracted light rays reach the person's eyes, his brain will trace them back and will assume that the light is coming from the point where these rays intersect. Hence, from his perspective, this will be the position of the star. This new position is known as the apparent position of the star, and this phenomena of changing the star's position by the atmosphere is called apparent shifting of star's position. Due to this phenomena, every star that we see in the sky is slightly shifted upward than the actual position. The magnitude of this shift is more towards the horizon, as in such case, the light has to cover a greater distance through the atmosphere. As the light rays passes through the atmosphere, they do not travel in a straight line, but they follow a zigzag kind of path. This is because the Earth's atmosphere is made of different layers. Each of these layers have different composition of gases. Some part of the atmosphere can contain more dust particles, while others can have less. Moreover, temperature also plays a key role. The part of the atmosphere where temperature is high will have lower density. On the other hand, the part where temperature is low will have higher density. That means different parts of the atmosphere have variable densities. So, as the light travels across various parts of the atmosphere, it keeps refracting continuously. These atmospheric conditions even fluctuate with the time. Therefore, the path taken by the light rays also changes with time. Now, let us see closely how the light is entering the eye. Suppose 5 rays of light are entering the eye at this point of time, for which the brightness of the star is this much. But since the atmospheric condition fluctuates over time, so maybe the very next moment, due to changes in some part of the atmosphere, this ray gets bent away from the eye. Now, 4 rays are reaching our eyes, so the brightness of the star will decrease. Again, let's say 2 more rays gets refracted in a different manner. Now, only 2 rays are able to reach our eyes. As a result, the star is going to look more dim. That is, its brightness will decrease. This continuous change in the brightness of the star is what appears to us as the twinkling effect.